Okay, we're going to talk about commercial wall systems, and these will sound like some of the information we had at the beginning of the year about walls. So we're not going to go through it super slow. In commercial, we're really talking about concrete, curtain walls, mason blocks, steel and concrete primarily in commercial buildings. In residential, we know it was mostly wood construction, but now we're talking about mostly concrete and steel. And there's two kind of walls, load-bearing walls and non-load-bearing walls. When we talk about load, we're talking about the weight of the building and all the stuff inside the building, and they call that the load on a wall or anything else we're talking about. So whenever you hear the term load, we're talking about the forces of gravity, the weight of it pushing down. A load-bearing wall means that that wall is strong enough to hold up everything above it. Non-load-bearing walls are just something that separates two areas. Non-load-bearing walls are lightweight, they only support their own weight, and they're usually just made so that they, separate two different spaces. Load-bearing walls, we could have wood, though we talked about it's not usually in commercial, precast concrete, and steel. And we also have CMU, which are those big concrete blocks, tilt-up concrete and cast in place. Concrete itself is made up of a number of different parts. You might think that it's just one solid thing, but it's actually made up of these different parts here, including the cement, which is actually what glues it together, whatever kind of aggregate we're talking about, which is the crushed up rock or shells or something, some sand, water, and then there's some air spaces. Advantages of concrete include the fact that concrete is really, really strong in compression. And later on we're going to start talking about compression versus tension. Compression is when we're pushing on something. If we're talking about a wall with weight above it pushing down, that's compression. And concrete is very strong in compression. It's durable, it's very fire resistant, and all these other ones. It's really a nice product to build with. What's the disadvantage of concrete? It's very, very heavy. So it creates a lot of load on anything that's below it. That's its only really disadvantage. You just watched the videos on LEED, which is our green building of it, and they now actually make some new green concrete as well. And some items that include here is we're talking about recycled materials, we're talking about materials that are coming from close by instead of being trucked a long way, and so on here. So there is some options for improving how eco-friendly our concrete is when we start building. Cast-in-place concrete is just what it sounds like. They make the forms, they put the rebar in. Here's the rebar like we saw before. Here's a closer up on the rebar. And then they have a cement truck or a concrete truck that comes and pours the cement right where it's going to be built. Cast in place, we usually have some kind of form on each side. The rebar is already in place and they pour the concrete in. And here's some examples of different concrete that was all built in place. You can really kind of tell because this still has the forms up there on these. You can see the forms on all these where they were building them as they were pouring the concrete into these forms as it was going up. And here's some more information on it. One of the ways that they can do it is they actually, instead of just having just the form, is they often put the insulation up there to begin with, and then they pour the concrete in between the insulation. Another option is tilt-up concrete. This is where they actually make the forms laying on the ground, and then they tilt it up into position. So here you can see where this is actually the wall, but it's laying flat with the rebar there, and this is a pump truck that's pumping the concrete in. They're going to lay all this out flat, and then they literally take a big crane and lift this up once it's made. One of the bonuses of tilt-up concrete is that you can use these little templates, and they put these inside those forms where you can actually get different textures on the surface of it. So it looks like brick, but it came from a form, or they'll go in and actually put these little like half-inch thick little brick pieces in the concrete before they start pouring it, So it comes out looking like brick. It's much cheaper than actually having brick and laying all the brick out, but it gets that look. Very often you also see this, for instance, along the highways where you have like those concrete walls on each side and they've got some kind of fancy texture on them. This is generally how they did it. And again, once they've done it, they can lift it up. You'll notice this one is actually a curved shape, which would have been very hard to build standing up like a cast in place, but wasn't hard with this curved form on the ground. Here's a little cross section of our tilt-up concrete. What you will notice is once they tilt it up, when they first poured it, they poured it with this little L piece in there. Once they tilt it up, they also have this little piece right here already built in. And this little piece gets bracketed onto this when it's tilted into place, so the crane lifts it up. And then they buckle it in right here. And then this piece was already sticking out like this. They tie this down to the concrete of the slab, the floor, and then they pour this concrete in. It basically locks these two pieces together so that this wall stays in place between these little brackets here into the foundation, and then this piece has been poured into the concrete there. And here's some examples of where they've used it in the past. That one's actually the Austin Research Center, and some other places where they've used tilt-up concrete walls. CMU brick. This is what we were talking about earlier. CMUs, these are these concrete masonry blocks. They're the kind of big ones that are like 1.5 feet long. They're actually hollow in the center. You can see the little hollow places there. And they're left hollow because when they stack them up, they put a piece of rebar down, and then every so often they fill those hollow tubes with concrete. So it's not solid concrete, but you do have concrete with rebar running all the way through to hold these all in place. You can see again here where they're lining them up, and then they'll come back, and here he's coming back and pouring concrete down into that one. The bonuses of this is that it doesn't take as much concrete, like a truck coming out and bringing your concrete out. And this is very low skill labor just to stack these up and put the concrete inside them versus finishing off actual concrete or a tilt up that would require the crane and all the extra equipment. And here's some examples of where they've used this CMU structure. It's often seen in schools, and many of the walls in this building actually have CMU, and then it has gypsum board over the top of it. It's very popular, it's very easy to construct, and as I said, uses less heavy equipment like cranes and such. Non-load bearing walls, they only have to support their own weight, so they don't need to be as strong. They're usually lighter weight materials. Curtain walls, wood frame, light gauge steel, and then the CMUs are sometimes used without the extra reinforcement in them. And here's some examples. You can see actually like this is not even attached to the ceiling above it because it's not actually bearing any loads from above. Here again, this is just lightweight. It's just holding up this little lightweight ceiling and that. Often this is a curtain wall. We will be putting a curtain wall into our library, or this is a curtain wall here, this big glass wall. Those are non-load bearing because they're literally made of glass. And they're made to provide lots of visual appeal, daylight, but they do protect from the elements. You see these all the time in commercial buildings, and they are called curtain walls, and we will be including them in our library. And that's the end of the video.